Hi there, today we'll be talking about SCANOSS.JS. SCANOSS.JS is a Node module and a CLI for interacting with the SCANOSS APIs and engine. Using SCANOSS.JS, you can scan your codebase for open source components, dependencies, and license compliance. Before we begin, we need to make sure that we have Node.js and npm installed in our system. To check this, you can open up your terminal and run node-v 24.11.1, perfect, and then npm-v. Version 11.6.2, great. To download and install the SCANOSS CLI globally, you can run npm install -g scanoss. Alternatively, you can install the SCANOSS SDK as a dependency in your Node.js project by running npm install scanoss. You can ensure that you've successfully installed SCANOSS by running scanoss-js in your terminal. As you can see, we get a number of commands that we can run. So version, help, scan to scan a folder or file, dependencies to scan for dependencies, WFP to generate fingerprints from a folder or file, crypto to scan for local cryptography, components for component intelligence operations, help to display help commands. Opening up a sample project in VS Code and opening up the terminal, I can run a simple scan by typing in SCANOSS.JS scan, mention the output file and the path of the project. This will scan against the free OSS KB. However, you'll be limited to the number of scans you can perform and the results as well. Now, in order to unlock the full scanning capabilities, I'll add an API key, and I can do so by including the ---- key and mentioning my SCANOSS API key environment variable. Pressing enter, give it a second. As you can see, it scans 7 files, which are the 7 files contained in my project right here. Once the scan is complete, you can review your results by going to the results.json file and inspecting each of the components. This file tells you what open source components exist in your code base, how much of your code matches to known OSS, provides information in regards to dependencies, licenses, provides information in relation to the match type. So in this case, this component here is a snippet match, mentions the number of hits, the line range for the actual match as well, the OSS lines, the match percentage, file hash, source hash, quality of the project, any cryptography related information, mentions the pearls as well, the vendor itself, the related URLs, mentions the status as well, meaning that right now this is an undeclared component, contains the URL hash, contains the licenses information as well, the health, and the relevant knowledge base metadata. The same metadata contains in all the other components also. So scrolling down, you can see the same thing. To scan for the dependencies, you can carry out the same command. Now in this case, you would actually include the ---- dependency flag. Press enter. Now opening up the results file, as you can see, it mentions the dependencies per component as well. So in this case, it would be vendor here, npm.js, component name, version, and source as well. Now using SCANOSS.js, you can also scan your project to identify any cryptographic related algorithm. And to do so, you can run SCANOSS.js scan, -o mention the output file, ---- cryptography and mention your API key. Additionally, also add in the path of the folder. Looking at the results file it just generated, we can see there's a cryptography parameter here, mentioning the algorithms it identified for each component and the strength as well. We can run the following command to generate fingerprint hashes of our project without running the analysis step. So SCANOSS.js WFP minus the output fingerprints.wfp and mention the project source. As you can see, it successfully generated the fingerprints related to this project. Now going back to the results file and looking at each of these components, as you can see, the status of these components are pending, right? Now in order to include and declare these components correctly, what we have to do is inside of the project source folder, include a scanoss.json file, and I'm populating mine with the following specifications. So I'm mentioning the settings, mentioning the BOM, mentioning the include rule, which specifies that each component under the source folder is related to the following Perl, including a comment mentioning that all source files identified as hyperwrap. Now there are a number of rules you can actually include. So you have include, exclude, remove, and replace, and based on your scenario, you could decide which one to use. However, in this case, I'd like to include all of the components under the hyperwrap Perl. Now to ensure my decisions are considered within the scan, what I have to do is run another scan, output the results to a results.json file, mention the API key, and mention the project location. Give that a second, and looking at the results file now, if I go to status, as you can see, all of the components are marked as identified, meaning that the components were declared and identified successfully. Additionally, I'd like to walk through the following settings configurations that you can also apply for snippet tuning within your scans. In the scanoss.json file, under settings, you have the option to add file snippet settings. Min snippet hits, which is the minimum number of snippet matches required before reporting a component. Min snippet lines, which is the number of lines a code snippet must span to be considered as a match. We also have ranking enabled, which controls whether origin project score quality is taken into account during matching. We have ranking thresholds, which sets the minimum ranking score from 0 to 10 required for matches to be reported. Honor file extensions, which controls whether file extensions are considered during matching also. We have skip headers, which basically skips copyright notices, import statements, and comments at the start of each file. And skip headers limit, which is the maximum number of lines to skip when using skip headers. And that's pretty much it. That's how you utilize SCANOSS.JS. Thank you so much for watching.